Meet our new kindergarten security guard. His job: to identify who's allowed to enter, parents and caregivers, and who might be a potential threat. Sounds simple, right? But there's a catch. He just started and doesn't know anyone yet. Every person who approaches the gate has unique characteristics. Maybe they're wearing an ID badge, maybe they're dressed neatly, or perhaps they're smiling confidently. These traits are like the input layer in a neural network, raw information the security guard observes. But not all traits are equally important. For example, an ID badge might be the most reliable sign of a parent, while a neat outfit might be less reliable. The importance the guard assigns to each trait is like a neural network's weights. The guard combines these traits in his mind, weighing each one carefully. This process of analysis is like a neural network's hidden layer, where raw data is processed and patterns are identified. Finally, he makes a decision: let them in or stop them. That's the output layer, where all the thinking translates into action. Of course, our guard isn't perfect. At first, he might let in the wrong people or unfairly stop real parents. Thankfully, the principal is there to correct him, just like how a neural network learns from feedback. Each time he gets corrected, the guard adjusts how much attention he pays to different traits, placing more weight on reliable signs, like ID badges, and less on misleading ones, like clothing. This process of trial and error is called gradient descent in a neural network. It's how the system fine-tunes itself to improve over time. After enough practice, our guard has become an expert. He can confidently and accurately identify who's who. That's exactly how a neural network works, starting from random guesses, learning from mistakes, and eventually becoming incredibly precise.